This video is a guide to how we can understand convection using the particle model of matter. For this video we will be using a PhET animation which can be found at phet.colorado.edu in order to help us understand what happens to a liquid or a gas when the temperature is increased. So in this container we have a volume of gas which is at a very low temperature. At this temperature, the atoms inside that gas are moving relatively slowly. They're also very close together. Now when we increase the temperature of that gas, what happens to the particles is that they begin to move faster. And because they move faster, when they collide with each other, they push each other further apart. This causes the overall gas to expand. The particles are spreading out. Now when the particles have spread out, if you think about a particular volume of that container, it now has less atoms in it than it did when the gas was colder. Because it has less atoms inside it, that means that volume will weigh less. And just like a helium balloon weighs less than air, hot air weighs less than cold air, and so that air will rise. Meanwhile, the cold air will sink. This is all down to the fact that the density of hot air is lower. The density means there are less atoms in the same amount of volume. If you imagine a volume of air next to a radiator, it will have a certain number of particles in that volume. If the radiator is at a higher temperature than the rest of the room, the radiator will pass on some kinetic energy from the particles in the radiator to the particles in the air. This is because the particles in the radiator are moving faster than the ones in the air. They're not moving very far because they're in a solid, but they will be moving faster because they will be vibrating. The moment a particle from the air hits the radiator, some of that energy will be passed along. So the kinetic energy of each individual particle in the air will increase. This will cause the particles to spread apart. Once they're spread apart, that same volume of air now weighs less than the rest of the air around it. Because of this, it will begin to rise. Once it's risen, some of those particles will make contact with the ceiling and pass some of their kinetic energy on to the atoms in the ceiling, at which point they will lose kinetic energy, and so therefore the temperature of that air will decrease, and also the particles will begin to move back closer together again. When they're closer together, that means it's more dense, that volume of air weighs more, and so it will sink.